Ready?
Yep.
Cool. Hello. I'm Andy. I'm the co-founder and CEO of Path Robotics. At Path, we make highly intelligent robots to replicate skilled welders. We do it because we have a major labor problem in the United States. In skilled labor, especially in manufacturing, we're seeing the demand and the need continuing to rise, but we are seeing the number of actual welders and the number of actual manufacturers and laborers continue to decrease. Right now, it's estimated to be about a 200,000 human welder labor shortage currently. But with the average age of a human welder being 55, in the next 10 years, 20% is estimated to be in retirement. And over the next 10 years, the next decade, we see the 200,000 number rising to 600,000. And if we didn't need human welders, this wouldn't be a problem. But today, 80% of the welding that happens in the United States is done manually. It's done by humans. And in defense, it's significantly worse. Over 90% of welding is done by humans today. And it's not because welding robots haven't existed. Over the last 50 years, GM has been running robots every day welding. But it's because of the difficulty of the problem. In defense, you have extremely high part variability, extremely high mixture of different parts. And then you have the most difficult welds. Welds that have to be extremely structurally sound to withstand all sorts of pressures, temperatures, resistance. It's one of the hardest areas to actually make robots work. And it's a huge issue today. What is actually going to happen if we were to get into a conflict? And we would need to scale rapidly. What are we going to do? Everybody in this room, you're going to grab a welding torch, a mask, and march your way down to Newport News and start welding ships again? That's never going to happen. And that doesn't look like a superpower that's actually dominant in manufacturing. For us to win and really reset and take back manufacturing, it's not going to be on the backs of humans. It's not going to be on the backs of traditional robots. It's going to be on AI robotics that create the workforce of the future. And at Path, that is what we are building every single day. Today, we're going to walk through two of our products. Our first one is our flagship product. It's called AW3. It does large-scale, heavy deposition finish welding, which is pretty perfect and works really well for a lot of the equipment that needs to be manufactured in defense. Tanks, armored vehicles, submarines, ships. All of these things have welding done on them every single day. All these vehicles need welding, and they need really hard welding. When we looked at all the parts that we are assessing, we came up with just basically a subsection, a small demo part, a small toy problem that we'd run today to actually walk through. And it's a joint. It's a 3/4 inch, full penetration, multi-pass structural weld, extremely common across all of these equipment, but extremely difficult to do, and to do at scale. So at Path, we try to make this as simple and basic as possible to operate. This is our software platform called Job Builder. You literally upload your CAD model, you click the seam that you want to weld, and you give it the welding specifications. So in this one, we're giving it the specification of 3/4 inch full pen. We execute, so we send this to our system. This is our perception engine basically running in real time. What we're showing you here is that every single part, every single joint, we do a 3D and 2D scan, collecting information that we need to make all the adjustments on the fly to ensure that the weld comes out perfectly. Our 3D scanning technology is built in-house. It's meant to handle high reflectivity, and in manufacturing, everything gets touched up. It also has accuracy of basically a human hair. Then we go into our understand. This is really the linchpin of why current robotics can't scale, why current robotics can't take on the job. Today, trying to understand where and how to weld is a very difficult problem that usually encompasses lots of humans in the process. You normally need robot programmers, welding engineers. You need to go out on the shop floor, test it, run multiple trials, adjust, and redo this over and over again. Here we have our foundational model running. We've been welding over 7 years in deployment at customers' facilities. We have collected millions and millions and millions of data points. These data points is what we utilize to train our neural networks in simulation to be able to make reinforcement learning work to build out full control policies so that we can execute flawlessly in real time on every single part. And then we execute. While we're welding, we turn the cameras back on. They're utilized to help monitor and ensure that the weld is hitting quality, as well as we utilize them to continuously collect data. The entire part of this is that we need to have systems constantly learn. In welding and in manufacturing, the amount of edge cases are crazy. The amount of different materials, titanium, all sorts of different alloys. Everything has to be learning. Everything has to be collecting data and constantly improving, or you will never get there. Started at welding, but that's really not where we're stopping. Welding is the heartbeat of the company. We've been doing it for 7 years, but we're expanding past it. We're now focusing on assembly and fixture building. We have our second product called AF1. This focuses on small parts, all the small parts that feed the larger parts. And this goes from raw components to finished assemblies. Same exact concept. It takes in CAD model as the only input. On the fly, it determines how to place and build its own fixturing setup. It uses force feedback and visual servoing to actually drive final piece-to-piece tolerances, and then it executes the welding. This system is really critical when we think about how do we get to fully autonomous fabrication, how do we get to lights-out facility so that run around the clock, day in, day out. I believe there will be a manufacturing facility I believe every manufacturing facility across the United States will have one of these in the next 5 to 10 years. We wanted to show you guys actual, just uncut CCTV. This is basically our security footage of this, the demo that we were just running. This is just it raw running. We've just increased the pace of video by 4x. But as you can see, there's just bins over there. It's doing unstructured bin picking. It's then doing reorientation of the part. It's then moving the parts over from the reorientation table to the actual table. It's using force to drive it into the positioners or into the fixtures. And then in some cases, it's using its own visual feedback to actually drive the final placement. We'll let this run one more second because I think it changes. No, okay. So at Path, we're really focusing on rebuilding American manufacturing. We want to take back the superiority that we once had in manufacturing, and we believe this is possible, and the possibility of doing this is now. And it's not going to be built again on humans or traditional robots. It's going to be built on AI robotics. If you guys want to connect later today, we have a little QR code. Please take a picture, and we're happy to connect after this. Thank you.